So, what does the law of conservation of momentum state? It says the total momentum of a system is conserved if there are no unbalanced external forces acting on objects in the system. Okay, that's worth memorizing. So, but what is a system? So, the term system or objects of a system, it means a collection of objects that we're observing. We define what objects are in the system depending on what we're trying to evaluate. You can put a single object in the system, 1, 2 objects in the system, 3. You could even put the whole Earth, or I mean, you could put the whole universe in the system if you wanted to. Kind of depends on what you're trying to observe. So it's kind of a concept. Um, so let's look at a situation with a bowling ball colliding with a bowling pin. At the moment of impact, I want to draw the free body diagram of the bowling ball and the bowling pin separately, and we're ignoring friction. So think about what forces would be acting on it. There, I've drawn the forces. So you've got the force of gravity on both of them, normal force on both of them, and then you have applied force from the collision. The collision on, or the applied force on the pin from the ball, and then the applied force on the ball from the pin. Okay, so if we want to define the system as just having the bowling pin, so I drew this dotted red line around there, what forces, if any, would be considered internal forces? So in this case, none of the forces that are acting on the pin are from objects inside the system. So none of those. They would all be considered external force. So gravity, where's that from? That's from the earth. That's not part of the system. The normal force, that's from the floor. That's not part of the system. The applied force, that's from the ball. That's not part of the system. So all three of those forces are considered external forces. Are there any external forces that are balanced, are canceling each other out? Yes, the normal force cancels out with the force of gravity. So those are external forces. Would momentum of the system of just the pin be conserved? No. The applied force is an unbalanced external force acting on an object in the system. So that force is still an external force, not being canceled out. Momentum of the pin is not being conserved. If you think about it, it started at rest, and all of a sudden it's like boom, going. So momentum did not stay the same. But let's say we redefine the objects in the system to be the ball and the pin. Okay. So what forces would be considered internal forces? Well, we kind of just went through that with just the pin, but the applied force, that's from the ball. And the ball is part of the system. So the applied force would be considered an internal force. And if you look at the applied force on the ball, that force is from the pin, which is part of the system. So those applied forces are considered internal forces. What forces would be considered external? The force of gravity and the normal force acting on the ball and on the pin. And so are these forces balanced? Are the external forces balanced on the single object? Yes. Both for the ball, the normal force and gravity are canceling each other out, and on the pin, the normal force and the gravity are canceling each other out. So in this system, would momentum be conserved? Yes, because the only external forces acting on objects in the system are balanced out. They're canceling each other out. So you just have internal forces of the applied force. So momentum of the system would be conserved. So how does that happen? So how does the force on the ball from the pin compare to the force on the pin from the ball? So looking at those two, they'd be the same magnitude but in opposite directions based off of Newton's third law. Okay, so how does the time that the above forces act on the objects compare? So which one acted for a longer period of time? Neither. They acted for the same time. Do you remember that collision with the Mack truck and the Volkswagen Bug hitting, and the force spikes going up and down? Okay, have the same force for the same amount of time. So, which object experienced a greater change in momentum? Check this out. They experience the same force for the same amount of time, therefore they'll experience the same change in momentum. The only difference is one had a positive change, the other one had a negative change, and that's determined by the direction of force that caused that change in momentum. So there you go.